Good morning, beautiful people. So how many of you visited the party yesterday? All right, good job. And how many of you visited our booth already? In case you missed it, it's right there at the entrance, but obviously I'll extend my invitation again. All right, so I'm Balázs Keszthelyi. I'm founder and CEO of the software R&D consultancy TechnoLynx. We do lots of things. Our core business model is basically to help startups and small to medium enterprises to enhance or develop their core technology. So basically how we operate is from initial brainstorming to whiteboard conceptualization up until POC level, where we hope to hand over something to our clients, which is having elements of novelty so that IP protection would be possible. Today, I'd like to talk about limitations of the AI as a service business model. One thing, for making my main points, unfortunately, I have to do some recap. So let's start with ethics. Wherever you look, there's always a little bit of a different interpretation of what ethics in AI would mean, but I would say that there's a fairly decent common ground that it would definitely has to involve representation, so that whatever data set are we using for training, it is representative with regards to social biases, for instance, whether it be race or gender or income level. Also, it's super important that any and every single piece of samples must be acquired via consent, especially when it comes to private information, but in the creative industry, it's also especially important for sampling. And according to the relevant EU guidelines, it's also very important that every kind of AI service that affects and probably adversely the outcome of the availability of some services to people. So let's talk about, for instance, loan applications. So if your mortgage is rejected, then you're supposed to have the right to know why, other than, I don't know, I just filled the form, AI said so, which is pretty much the default with deep learning systems. Yes, and for the creative industry, I would say that there are a number of additional challenges. So first and foremost, the sampling behavior of AI systems is critically important. So since generative AI systems are ultimately at their core compressors, we could argue that whenever they generate something, in reality, they basically take a sample from things that they saw already. Now, if you're an artist, you have most of the time some conscious ability to recall what was your influence. Now, the same thing, unfortunately, and you can reference it, same thing is unfortunately not true for AI systems, so that's obviously creating a problem. Second problem is the issue of copyright. And it's not only about like whether you get the rights, somebody is, assigning it to you on paper. It's like whether it is even possible to get the right, because as we said, if the theory is that we are sampling from something that existed before, then it's not really creation, is it? Third point is that some of you are creatives anyway. I'm more like talking to some creatives, but one thing I hear commonly is that yes, there are some ways to control the outcome, but it may not necessarily agree with their specific artistic style, so it may lead to dissatisfaction. The other issue is like, where can you apply generative AI? Because not every kind of asset is equally critically important for delivery. So for instance, if, I don't know, there's an artifact in one of the boots of your NPC in a game, that's, you can probably get by. But if you try to do something like level design and the playing character is supposed to get an item from a room which doesn't have doors, then that's obviously rather more problematic. And the fifth element is actually what's also very important, is that current systems are mostly operating on a basis that any kind of control that you can exert, it's at the beginning of the pipeline, and it's not exactly a communicative process. So it's inherently different compared to how humans would operate via a series of back and forth communication. So how do you inject human supervision and feedback is a non-trivial matter. All right, what was the promise of AI as a service, both as a business model and the technology? So it's very important to differentiate two separate aspects. So one is that how people came across to AI as a service. It was basically a promise of a new business model that's a sign of maturity, that okay, people were playing with AI already, but now it's mature, it's finally grown up, you can pay for it. That's a sign of being a grown-up, and in general, the companies offering it figured out ways to enable ecosystems, so basically products operating on top of other AI services. And it created this sense of the future that, okay, so now it's all about big tech. So if you did anything at whiteboards, then, you know, drop it immediately because now it's only available from big tech. For most people, this change has happened at the same time when multimodal AI came to reality. So now everyone takes it as a default that our current AI solutions are capable of both ingesting as well as creating output, whether it be audio, video, images, and text. And that's really something to celebrate because this is the most advanced way of human and machine communication that we have ever seen before. On the other hand, it's also important to highlight that it's basically a packaging, but in reality, AI as a service did not create these things. It didn't enable these advancements to happen. It's just building on top of it. Obviously, all these changes has triggered these talks about replacement of knowledge workers or replacement of creative workers, and obviously there are these talks of, I don't know, developers versus creatives and how the balance is shifting. But in reality, it's not really a game like that. So for instance, entry-level developer jobs are just as much affected by changes in this industry than it happens for the creative part. But in reality, at the current maturity, it's pretty clear that these changes are much more about augmenting human workforce at the moment, at least. All right, let me recap some very basic things that, okay, how do even neural networks learn from deep learning perspective? So all you need to understand, I mean, this is a kind of diagram that you probably saw a million times. So we talk about some layers of interconnected neurons, ultimately producing some level of output. So the core fundamental thing you need to understand that the neural network is something that works forward and learns backwards. And how does it work is a fairly intuitive process. I mean, the learning part. So basically, you, in supervised scenario, you take input samples with expected output. You just feed in the input sample, it does whatever it does, and then you compare its output with whatever it should have been. You take the error, and you look at it, and you're like, okay, how should I have changed things here so that I get the desired output? Okay, but to get that input here, I should have changed these guys as well. So I step back one layer, and I step back again, and I step back again. This is called backpropagation, and the thing that you are propagating is the so-called gradient flow. Flow is generally sounds good, so this is something we would want to keep it this way. Why is it important to you? So obviously, once you have a neural network that is able to accomplish some kind of a task for more complex systems, you would want to combine these neural networks. There are multiple ways how you can do it, but I would say the natural way is that you interconnect the neural networks themselves the same way as you would interconnect the individual cells, neurons. Now, if you're doing that, it enables some very beautiful synergy because the different neural networks kind of become aware of each other, and as they are learning, they can also become able to compensate for each other's mistakes. So this is how you can get the maximum performance out of neural networks. Obviously, there are some other ways. For instance, you can have concepts of competition. Competition is sometimes a good thing. So for adversarial networks, and also there is the black box way, in which case you can't really fully connect the neural networks. It's like they are working together, so you can do that, but you can't really learn that way. I'll explain later why. All right, so as I said, what's beautiful about the natural way is that inference, so how they work, is operating, but at the same time the gradient flow via backpropagation is still operable. What we don't necessarily like about the black box way is that, let's say that we have some neural networks that we manage to connect the natural way, and in between them we create black boxes. Now these black boxes can be many things, but let's say that they are, I don't know, REST APIs in an AI as a service solution. Now in that case, what you love so much that, wow, I just need to program an API, basically it becomes a stone wall that's preventing the gradient flow from operating. So this is already limiting your ability to actually build really custom, really complex things with these systems. It's also very important that, obviously, AI, deep learning is not perfect. So the same way as it happened with regular software, you will need to do fixes. Okay, the issues this time will not come in forms of bugs, I mean some lines of code that you wanted to fix. Instead, the way how you fix the behavior of a neural network is like more than 90% of the time is about reevaluating, like whether you were training at the right data, whether it was representative enough, whether the samples are correct, whether it's covering a large enough variety of use cases, whether you can gather more data or you need to simulate more data. And once you did everything with the data, there are still tons of things that you can do. So you can play with the loss function to change the mathematical optimization problem. You can change the topology. You can and must play with the capacity, because actually the desirable level of capacity depends on the available data's quantity. And anything, every single thing that you do is triggering the need for retraining. Now, let's revisit this beautiful diagram about the anatomy of AI as a service. So all of these solutions, because of the current definition of these REST APIs, are operating as black box. Yes, you can't really learn from these combined systems, but actually even if you just wanted to fix something, you don't even know what was the data it was trained on. You don't have like control over it in any way. If you wanted to tinker around with the loss function, well, good luck with that. And basically you can only observe the external behavior. Now, what does it mean? How to translate this to business? So basically, yeah, quality control is like non-existent. So if it's broken, you ain't gonna fix it. Now, even the customization and the differentiation options are quite limited, so most of these models offer you a way to enable refinement training on top of a baseline training. I mean, okay, that's not a too bad thing to do, but basically you either feed in some extra data for refinement training, but the impact may not be as big as what you hoped for compared to the much like order of magnitudes bigger training data on the base model. And also the other way is that you can feed in context, but if you, for instance, played with the earlier versions of ChatGPT, then it was very prevalent that it's actually forgetting the context. Now, even the latest version is also forgetting the context. It's just bigger and it lasts longer, but it's inherently there, that issue. Another thing is that because you use the same ways how you can customize and differentiate your offering, it means that whatever you set your mind on, it's going to be a very similar solution to whatever all your competitors can also do. So that's probably not a recipe for building a moat for like a sustainable long-term business. Obvious issue is privacy. In some industries, companies just don't want to have things up in the cloud, and in this business model you don't have any other options, so you can't really do like the data center hosted version of anything that's built on AI as a service. And ethics. So even if you wanted to build the most ethical AI company ever, it cannot be any more ethical than OpenAI is, for instance. And okay, you can read the guidelines, but in reality you will never know how ethical they are. Also, let's say that, okay, you don't care about any of these things, you just want to push out something. That's great, but let's look at the consequences. So for instance, in OpenAI's case, last year they were doubling their loss to $540 million US. you could say like, okay, who cares about last year? So it's all about, this beautiful year of the growth of ChatGPT. Awesome, but even in this year, they don't expect more than $200 million revenue from ChatGPT. You could argue that, okay, but who cares? I mean, these guys are like miracle workers. They are working towards artificial general intelligence. So this is just some initial investments to accelerate the pace of delivering something great. Except that, the famous quoted leaked Google memo states that actually neither Google or OpenAI actually has a moat. What's the reason for that? So, okay, some argue that open source is outpacing big tech. I mean, it doesn't really matter. So even if you believe that big tech is ahead thanks to these investments, basically what we are talking about is spending at least 340 million in investment to get a few months of advantage, basically, compared to a very strong open source baseline. And obviously, if you are building your business on something that's where the underlying tool and ecosystem is built on a non-sustainable business model, then that will very profoundly affect your business too. So what's the way then? I mean, get bold and do custom. So obviously that's the answer you could get. Okay, I mean, very poetic question. Are there any advantages to these AI tools? On the other hand, I mean, AI in general, yes, sure. So one thing that's not on the generative side is that it's pretty much in every AAA game launching now. I mean, there are some AI super resolution solution. What was even the motivation for using AI for this problem? Okay, so first of all the display resolution got pretty crazy even on the mobile devices recently. The other thing is that when it comes to AAA, the enablement of real-time ray tracing needed some resolution subsampling techniques, because without it, ray tracing is scaling. I mean, the performance cost of it is training a lot more with the resolution rather than the geometrical complexity. Now, you could upsample images before, yes, but using linear filters having one inherent limitation is that, I hope some of you learned signal processing. So basically the law about that one is that when you introduce subsampling, you're also introducing aliasing artifacts. And once you did that with another linear filter, it's not possible to reconstruct the original image anymore. However, with a nonlinear filter, like AI solutions are, it might be possible. So that's what you can follow with all these different iterations of solutions out there, from FSR1, which was basically hand-tuned linear filter, to DLSS and XCSS neural network-based solutions. So these guys actually function pretty well as anti-aliasing techniques as an added benefit for super resolution. Let me tell a few words about generative AI as well. So this will be important to understand conceptually. So generative AI solutions at the core of them are compressors. So this is, for instance, a diagram of a so-called autoencoder. So any kind of domain that you look at. So for instance, let's say the domain is the set of images of faces. So you feed it in and you create a abstract representation of the faces that's like much smaller. That's what we call the latent space, and every sample in the latent space is a so-called latent vector. Now, how you should think about the latent vector is that basically that's a entangled, very compressed thing for things that you don't actually have control over, but you want to sample from. Now, obviously, I said, though you don't have control over, so yes, you can generate faces like this, but it's not going to be very customizable. So first track was, okay, let's add some direct customization options. Normally that's via segmentation, but obviously it could be as simple as like, let's just doodle something that's generally setting the structure of a face, feed it in as like auxiliary data, we call it condition, and the combination of condition for structure and style for literally everything else, including skin color, hair color, and so on and so forth, would create images that are, as I said, closer to what you wanted to get. And then you can play with the styles. So you can, for instance, most natural way is that you can interpolate between two styles. That's basically what's happening here. So we have two faces generated, and the third one that's like in between the two with regards to its features. Also, you could try and figure out some ways to control only any one of the particular attributes in style. And to actually get really good results, you may want to introduce some very fine granularity to this style control. Now, to turn this into something more practical, so imagine that for asset generation, you may want to, I don't know, create models for a city, or at least for interior for a room. So with hierarchical style control, you could build something along the lines of, okay, I want to have like a generally medieval or Baroque or whatever city center, like it's generally the case in Hungarian city of Szombathely, except that there is some, you know, ugly landmark, which is a brutalist post-socialist building here next to it. So there you want to control the style in space, like where do you apply what kind of style. On the other hand, you could say the same thing like with a sharp delimiter in rooms, and you could say like, okay, left side is the furniture that you inherited from your grandma, and the right side is the brand new IKEA furniture. But you could do more interesting things like having gradients of styles interconnecting with each other, and so on and so forth. So the reason why I'm talking about this is that one common pattern that I noticed is that most of the generative AI solutions today are NLP driven. So, wow, I don't have to be an artist. I can just explain what I want to do. Okay, great. But what about if you are an artist? I mean, I don't know, Michelangelo got there and started talking to the marble to get a sculpture, or like, no, so seriously, that's not how these things work. So you may want to create tools that are more naturally fitting to the creative process of how artists think and how they want to interact with the art that they are creating. And that's why I say that it's very important to understand this concept of condition and style, because this is the law of nature part, basically. So if anything that you can express with these things is possible. All right, so I would say that we are very happy to welcome you at our booth, where you can see some of our demos live. So for instance, these pictures were coming out of our own face mixing demo. Actually, this whole face mixing concept is something that you could see quite a few years back. And as you will see visiting our website, that we are very much not a UI company, especially not UX. So I'm a bit apologetic about this, but the main point is that on the negative side, this is like a fairly classical variational autoencoder model with some added features, basically bring it up to speed with more contemporary GAN models. Okay, but what's the cool thing about this is that we wanted to demonstrate is that it's not only as good that in reality you could do and solve most of these problems that you need AI as a service solutions now with custom solutions. I mean, you did know that already, but actually on the privacy level, you could create 100% private full edge computing solutions, and that's the cool thing about our demo, that it's running everywhere, it's running on our mobile, etc., and it doesn't use any server-side code, so it's 100% on your device. And the other tool that we were working on is basically a chess game. We try to answer two questions, basically like, is deep learning the answer to everything? Of course not, and actually we just managed to replicate what was kind of known already, that for games AI, actually deep learning can be good to augment classical algorithms, but in many cases actually the highest performance you will get with hybrid algorithms. So for instance, you can choose quite a few of the AIs you want to play against in our system, but the highest performing one is actually a variation on a classical model. The pure deep learning solution is pretty much the worst that we are having. But we also wanted to explore an idea like, could we enable new ways for gamers to interact with the games? So this one is not our model, we just picked an open source model, but we integrated gesture recognition to the AI system. Still, it's running 100% in your browser, so also mobile friendly. So additionally to tapping, you can also just grab basically the pieces via gesture recognition, which is something that a few years back you needed like special hardware in age of Kinect, but now like consumer devices can also achieve this feat. And yes, and obviously if you want to look at what we are otherwise capable of for commercial projects, then please come to our booth and do a dental simulation of your smile. So this is something that we did for one of our most loyal clients. Basically, these are the before and afters, and like I said, we are at S20. All right, so thank you very much for listening, and again, I would invite you to our booth, and other than taking a look at these demos, which by the way you could have already done on your phones, we are running a raffle for people who are happy to answer 2 questions about their future when it comes to AI, and also if anyone dares to try and beat our chess engine, then they can also enter a competition leading to winning a bottle of Tokayasu. So yes, that's it on my side. Thank you very much.